Hello. Today I want to talk about the inverse Laplace concept, particularly for systems that are in a typical mechanical system consisting of a mass spring damper, are known as underdamped system. So let me start actually with the Laplace of some basic functions like sine and cosine. So if, for example, we have a function in the time domain and that's equal to sine omega t, omega is just the frequency, then the Laplace of this, and as you know the notation is f of s, so we go to the s domain, would be the frequency omega in the numerator divided by s squared plus omega squared. Similarly, if the function is cosine omega t, then the Laplace of this would be a little bit different. That s would go in the numerator and we would have the same thing in the denominator, s squared plus omega squared. So for example, if we have some function, let's say in the s domain, and we have something like s divided by s squared plus 9. So you see 9 is the omega squared. So if you want to go do an inverse Laplace and go to the time domain, f of t then would be just cosine of 3t. So this is what we call inverse Laplace, going from the s domain to the time domain. Now, also, if you have some function of time attached, say f of t, attached to an exponential of the form of e to the minus at, then the Laplace of this would be just whatever the Laplace of f of t is, but translated by a. So it would be f of s plus a. For example, if, say, our function is cosine omega t times e to the minus at. So what would be the Laplace of this in the s domain? According to the equation up here, right, we would have s divided by s squared plus omega squared. But anywhere you have s, the s would be translated to s plus a, and in the denominator again you have s squared, so that becomes s plus a squared plus omega squared. So let me go to the next page and give you an example with numbers. So let's say your function in the time domain is e to the minus 2t, say cosine of 5t. So what would be the Laplace of this? So you see a here is 2 and omega here is, so that's omega and that's a, right? So it would be s plus 2 divided by s plus 2 squared plus 5 squared, which is 25. Okay? So these functions, these type of functions are important when we do inverse Laplace. So what we want to do actually is, what if we were given something like this here, right? And we wanted to actually get that. So that would be the inverse Laplace. So for example, let's say if you have a function that is of the form, say some function in the s domain, and is equal to, say, s plus 6 over s squared plus 2s plus 10. Look what I'm going to do with this. Later on we'll see that actually when you look at this, is the characteristic of the function, kind of like a transfer function of the system. And this is of the type that if you try to find the roots of s squared plus 2s plus 10, you'll see that you get two complex conjugate roots. So in order to bring this back to the time domain, we have to do some work here. So for example, we do what we call completing this square. So you see this s squared plus 2s plus 10 can be written as s plus 1 squared plus actually 9. And then we have s plus 6 up here. Then look what I'm going to do. I'm going to actually rewrite this. In the numerator, I'm going to change the s plus 6 to s plus 1 plus 5, divided by s plus 1 squared, plus, and 9, remember, is 3 squared, right? So, but then I could break this into an s plus 1 divided by this denominator, s plus 1 squared plus 3 squared, right? And then I can add 5 over the same thing. And then look, this term is going to go back as some exponential function times cosine. And this I can modify. See how I'm going to modify? I need an omega up here. My omega is 3, so I'm going to multiply by 3, and I'm going to divide by the 3. So look what happens now. When we go to the s domain, rather time domain, my function now is going to be e to the minus at, which is a is 1, and then this is cosine of 3t. And look at the second term. The second term is also e to the minus t times sine 3t, but remember there is a coefficient in front of it, so let me actually erase this and put the coefficient. What is the coefficient? As you can see, that would be, see, 3 is already used here, so it would be 5 over 3. So this is going to be the function in the time domain. In other videos, I will show you how this function will look like. This would be an underdamped system. Thanks.